So guys, I came across this particular question in Physics 101. Very interesting question, okay? And the question is something that I really have this full confidence on, that it is a CBT-like question. Yeah, that is a computer-based test question, which means an examiner can easily test you on this question, all right, when it comes to your examination. I'd like you to follow along as I read the question. It's going to appear on the screen. Then we would see how we can use the knowledge of the known to deal with this question, which otherwise someone might feel that the question is tough. But I've always told you, once you are prepared, right, you understand the principles, these stuffs are going to be 1 plus 1. And GMAT 41 is always here to make that happen. So this is a question, all right? A body of mass 0.5 kg is attached to a spiral spring and set into oscillation. If the velocity of the body is given as v equal to 3 sine 2.25 t, calculate the total energy of the system. So that's the question. Now, what might sometimes a kind of threaten someone is because you saw a function, a velocity function, but hey, this question is 1 plus 1. Let us see how we solve this problem, just in one shot, okay? Follow along as I make the analysis, and you'll be very surprised. So this is how simple this question is. That is why I always encourage you to be confident in yourself. These stuffs you're doing, they are really easy. Get a good coach, like GMAT 41, and you will enjoy all of these stuffs. Let's do this together. So here we have the mass m to be equal to 0.5 kg given, and then we have the velocity function, all right, of this mass that is undergoing this oscillation. The velocity function is given as v equal to 3 sine 2.25, and then t, 2.25 t, please. There is no w there, 2.25 t. That's what the question said. Now, we are required to obtain the total energy E. We do not know. We do not know. So the question would be the total energy of a particle undergoing oscillation is given as what? In one of our previous videos, I had solved something like that in a live stream section. One of the workbook questions from Unizik Physics 101. I explained how you actually deal with, the concepts of solving the total energy in simple harmonic motion case. So I'd like you to recall that total energy is equal to 1 over 2 Ka squared. This is the formula we need to use to solve this problem. I see that this question becomes simple. Now, if we need to use this formula, then you see that you need the value of K, which is the force constant, and you need the value of the amplitude, A. Okay, so once you know the force constant, or the spring constant, and you know the amplitude, all right, just substitute here and then you solve. And so now that I have given you the formula, the next thing is for us to move on to obtain K and A. So how do we go about getting this? Now, we are given this velocity function, all right, under circular motion and simple harmonic motion, where this question is taken from, because this question is a simple harmonic motion problem with a mass attached to a spring. Now you find out that the velocity function for a particle undergoing this motion we are dealing with, it can be written as v equal to negative AW then sine WT, neglecting the phase shift. We don't need that because of the velocity function given. That plus phi or whatever is not necessary there. And now, this equation you are seeing, see this quantity AW, that is the magnitude of velocity, which means that the magnitude of velocity is equal to AW. We are saying that the magnitude of the velocity is equal to what? AW. Now, if you compare this velocity function with the one given to us in the question, look at the relationship. V equal to. Now, this 3 is equal to minus AW. But there's something about magnitude. Magnitude has no business with negative. The magnitude of any quantity is always positive, which means we do not have any business with this minus when we are equating to this 3 here. Are you following, right? The idea is that 3 is equal to AW. That's it. Alright, so it implies that if you compare this equation and this, this guy was obtained from differentiating the position function, okay? Position function is A cos WT. So if you differentiate it, you get negative AW sine WT. And I'm trying to talk a little about this because these are bases, fundamentals that you need to understand so as to be able to hold your examiner to ransom, Hold him or her to a standstill when you are given a question like this. You smile and say, come on, I'm set for you people. You've got nowhere to dribble me to. So we move on. I am going to say that 3 is equal to AW, okay? Or I can say it implies that AW is equal to 3. If AW is equal to 3, we can actually determine other values. We can determine other values. And how do we do that? Watch. Now we have that AW is equal to 3. Look at again. If you continue, this is sine, and then we have 2.25. This is W, we have T. So what's the idea here? 2.25 is equal to W. 2.25 is equal to W. So I can say also, we have that W is equal to 2.25. So if I do my substitution, the implication is that the amplitude times W, which is 2.25, is going to be equal to 3, and then we can now solve and get our amplitude. Amplitude is equal to, divide that 3 by 2.25. If you divide 3 by 2.25, let's see what we're going to get. And then this gave us 1.33 and then 333. So let us pick 1.33. Now I'm going to write it in meters because amplitude, the SI unit is meter. Now that I've gotten my A, from all this comparison, are you following, right? So that is why when you are studying quiz, you are studying your textbook or you are watching a video lesson, you want to be interested in basic concepts. It's not just all about rushing into solving questions and you're preparing for exam and it's just question. Try to understand the fundamentals. Once you do, let me tell you, all these other questions given in exam and assignment, they will really be 1 plus 1. Yeah, the way. Now let us move on. This is in meter, like I said. We have been able to get our A. So we are left with getting K. And how do we obtain K? We know our W already. Okay, we know our W already. From simple harmonic motion. Now you notice that W is equal to, square root of, okay, let me make it W squared is equal to K all over M. So W squared is equal to K over M. That's the idea. Now from there I can get my K. The implication is that K is equal to W squared M. And then substituting, K is equal to our W. From here is 2.25. So we're going to square it and multiply by the mass. Come to the question, the mass was given to be 0.5 kilogram. So 0.5. And if you work on this, what is going to be the value of K? Let's find out. We're going to square 2.25. And then we'll multiply by 0.5. So do that and then you get 2.53. That's the value of K. 2.53. 2.53. And the unit is Newton per meter. Now that guy is spring constant, elastic constant. So you can take your mind back to Hooke's law of elasticity. The unit of that guy is Newton per meter. And of course our problem is solved. We know A already, we know K already. We can now calculate what? The energy. We can now calculate the what? The energy of this object undergoing this oscillatory motion. Is that okay? We can calculate the total energy. So all we have to do is that E is equal to 1 over 2 times our K. K is equal to 2.53 and then multiplied by A. And our A is 1.33. 1.33. Then you square it because this is A squared. Now simplify this, you get the total energy. I will not get to that end. Alright? Drop your answer. Drop your answer in the comment section. I hope you enjoyed this video lesson, right? And I hope you appreciated the way that this has been made 1 plus 1. Please give this video a thumbs up, like Jimas41's video, share it to your friends, to your classmates, to all the scholars, so that they too can come across this video and learn more as you all prepare for your examinations. Don't forget to subscribe if you have not done so. Hit the subscription button, turn on the notification bell so that whenever I upload any content, you will be personally notified. And please, I encourage you to become a channel member. Click on the Join tab just below this video and then select one of the GMAS 41's packages. I appeal to you to go for the Platinum level and above. Become a channel member, support this channel so that GMAS 41 will continue to give you the best. And don't forget, on this platform, for those in Unizik, your workbook solution, they are all available here. Become a channel member and you get access to them. And if you want to join our physical tutorial on campus in Unizik, feel free to contact GMAS 41 so as to get the direction to our venue on campus. Join our physical tutorial and we'll get you prepared for your ace splashes and first class in view. I'll be seeing you in my next video.